Okay, solving quadratic equations. As we're thinking about doing this, we're going to focus on two main things: the zero product property, which includes factoring of one side, and the quadratic formula. Now, the quadratic formula is very handy. It'll solve every single quadratic equation we're given, and the general form for a quadratic equation is ax squared plus bx plus c equals 0. In both these cases, we want to have 0 on one side by itself first. But for utilizing the quadratic formula, there's not a bunch of insightful things I can tell you about this, right? It's a formula. It's very, very handy. I would suggest memorizing this, getting it down. The a, b, and c come from the coefficients on these first two terms, and then the constant here at the end. You basically just locate what those numbers are, plug them into this formula, and work your order of operations to simplify down. We're going to instead focus on the zero product property and practicing factoring. Now, it's important you have 0 on one side by itself here, because not a lot of things multiply together to give you 0. Now, if this was 20 on the right-hand side, there are a lot of different pairs that give you 20. Right? We could say 1 times 20 or 2 times 10 for our a and b over on the other side. 4 times 5, right? But to get two things that multiply and make 0, either one of them 0 or the other one 0. Or maybe both of them are 0, because 0 times 0 also gives you 0. So let's jump right in and practice a little bit of this factoring. So whenever you're thinking about factoring, the first thing you always want to do is get everything on one side and 0 on the other side. So to accomplish this on this first one, I'm going to subtract 6n from both sides. So that'll give us 2n squared minus 6n equals 0. We can't combine those two terms together because they're not like terms. They aren't both raised to the same exponent. The next thing we want to think about when we're thinking about factoring is, do all the terms have something in common? Do they have a greatest common factor? So in this case, they both have a multiple of 2, and they both have n's. So I'm going to factor out 2n from these terms. So I think to myself, 2n times n would give me the first term, and 2n times negative 3 would give us that second term. Now we can double check if we wanted to redistribute that 2n from the outside to get rid of our set of parentheses. That would be okay, and we should get those same two terms back. All right, from here, we're to the point where we have two things multiplied together that equal 0. So I'm going to finish this up by setting each factor, is what we call those, equal to 0. Treating these like separate problems and then solving them down. So the first one, I'll just divide both sides by 2. We get n equals 0. The other one, I'm going to add 3 to both sides, and we're going to get n equals positive 3. Now we could check these solutions by plugging them back in, replacing each of the n's in the original equation, and find that the left side equals the right side. That would reassure us we did everything exactly correct. Let's jump over to this one. So if we're looking at x squared minus 5x equals 6, first step is going to be very similar to the other one. We want to move everything to one side. So I'm going to subtract 6 from both sides, move that over. The next thing I want to do is, because it's a 1 out in front of our x squared, that's a little bit easier problem than one we're going to see very shortly. So because it's a 1 out in front, if I can factor it, I know it's going to factor as two binomials. In this case, we don't have any greatest common factor except for 1 for all three of our terms. Now the first two both have x's. There's an x here and an x here, but that last one doesn't have an x, so we can't say x is in common for all the terms. Next, splitting this apart, I'm going to go ahead and these first terms, as I write them out in these binomials, multiply together to give us that first term. So x times x is going to make the x squared. But then whatever I place in these other two have to multiply together to give me this 6. So what I like to do is, off to the side, I'm going to go ahead and write 6. And then I'm going to list out all the different ways to factor 6. We can factor 6 as 1 and 6, or 2 times 3. No other integer factors anyway. All right, next, I always look and I say, well, that's a negative 6 at the end there. So what I want to do is pick out the pair that I've listed off to the side that subtracts to make the middle coefficient, that 5. All right, so 6 minus 1 makes 5. 3 minus 2 makes 1. So I'm going to go with 1 and 6. All right, the last thing is getting the right signs on these. All right, I want these two to, what I've underlined here in red, I want these two to add together to make a -5. Okay, so in this case, I think we have to go -6 plus 1 makes -5. We could double check this by multiplying it back out and making sure that it was x squared minus 5x minus 6. But I think this one's going to work out okay. To finish this up, we're going to set each factor equal to 0. Treat them as individual problems and solve them down. So subtract 1 from both sides, add 6 to both sides, and we end up with 2 solutions on this. We could check our answers back into the original one at a time by replacing both the x's with -1 and then both the x's with 6. Let's do something very similar on this one. So getting started, you get 0 on one side. So in this case, we're going to add 6 to both sides. I don't have a greatest common factor besides 1 for all 3 of the terms. So I'm going to jump right into seeing if I can factor this as 2 binomials. Again, x and x make the x squared in front. Again, I'm going to list 6 off to the side as my constant. Think 1 times 6 or 2 times 3. This time, it's a positive constant, so I'm looking for the pair that adds together to make 6. Sorry, adds together to make our middle number 5. So this time we go with 2 and 3 add together to make 5. So I'm going to use 2 and 3. Now I have to make sure that if I were to combine these together by adding 2 and 3, we're going to get a -5. So in this case, I think we have to go -2 minus 3 more makes -5. We could double check, multiply it back out if we wanted to, but I'm pretty confident on this. So let's set each one of these factors equal to 0, solve them down. This one we're adding 2, this one we're adding 3, and we end up with 2 distinct solutions. Could check them if we wanted to. All right, one last problem on this video. This one's a trickier one. It already has 0 on one side, but what makes this more difficult is we have a 4 hanging out in front. That if you have a leading coefficient that's not just 1 out here, it's a little bit more involved. So I'm going to run us through what we refer to as the AC method for factoring. It's referred to as the AC method because remember we said that's a x squared plus bx plus c. I'm going to go ahead and multiply 4 and 3 together to get my number that I'm going to list off to the side. And I do realize it's a -3, but I'm going to ignore that for right now as I list my number off to the side. Next, I'm going to list all the different ways we can factor 12. And by the way, the AC method works every single time, all right, on the first try. So if you're wondering, like, how do I get good at factoring, you can always use the AC method to help you out. But 1 and 12, 2 times 6, or 3 times 4 all make 12. I like to be systematic as I list out these pairs as well. All right, next up, I look and I say that sign is a negative. So I'm looking for the pair that subtracts to make an 11. Well, in our case, 12 minus 1 makes 11, so I'm going to use 12 and 1. This is where the AC method looks weird. As far as if you've never seen this method before, let's roll through it. The first term comes down. The middle term gets split apart. I'm going to strategically rewrite that as 1x and 12x using those the same numbers as our coefficients that I circled over on the right hand side. Then the -3 comes down. From here we're going to be careful that those are now like terms that I've split apart. If I combine them back together, I want to get back to this positive 11x. Alright, so in order to make that happen, it's got to be a positive 12 and a -1. 12x's minus 1x gets us back to 11x's. Okay, from here we've rewritten it strategically with 4 terms. What we want to do is factor by grouping whenever we have 4 terms. That should be our thought process. So for factor by grouping, what we do is we just group the first 2 terms together, say to ourselves, what do they have in common? Well, those first 2 terms, 4x squared minus 1x, both have an x in common. So what I'm going to do is factor out an x from those 2 terms. That'll leave us with 4x minus 1 inside our set of parentheses. And then I look at the last 2, that 12x minus 3, that pair, and say, what do those have in common? Well, they have a 3 in common. All right, but I also know for factor by grouping to work, what's going to have to end up in that second set of parentheses has to match what was inside the first set of parentheses. So sometimes I like to think about this as kind of working backwards. I think to myself, 4x times what gives us a 12x? Well, 4x times 3, and it's going to have to be a positive 3, would give us a positive 12x. You can also double check this by saying, well, if I redistribute this 3 to both these terms on the inside, do I get those same two terms that we had up above back? All right, the last thing we want to do on this is what's out in front of our sets of parentheses. The x plus 3 is going to go in one set of parentheses. And then what's inside the set of parentheses, 4x minus 1, is now a common factor. So it's going to go in the other set of parentheses. And it's factored. All right, so to finish this up, set each factor equal to 0. Solve them down. X is negative 3. On this, it's going to require a couple steps where we add 1 first, then divide both sides by 4, and we get x is 1/4. So again, we got two solutions when we get done here. We could double check both those solutions by plugging back in one at a time for both of those x's. So replace both of them with negative 3, then replace both of them with 1/4. Hope this helps out as we get good at factoring. This skill pays off big dividends as you keep working forward in the semester.